Welcome once again to Algebra 1 video lectures. We're going to work on chapter 1.4, the distributive property. Now, you might have been thinking last chapter that this stuff is pretty boring and kind of obvious. Why do we have to do it? Well, I gave you the reasons last time, but the distributive property is much better. And I'm just going to write that down. Distributive property. This is one that you use all the time, and it's not super obvious, and I'm pretty excited to tell you about it. So, the distributive property is pretty useful when you're solving equations and you need to figure out how to move variables around so that you can plug in your numbers and simplify. So, let me just give you an example of the distributive property. The distributive property says that for any numbers, A, B, and C, you can do a couple of different things. The first is that A times B plus C is the same thing as AB plus AC. And also that if you have B plus C times A, that's going to be the same thing as BA plus CA. So check it out. You can distribute in either direction, whether the first variable comes ahead of the parentheses or after the parentheses. Now, this is pretty powerful. We won't talk about all the uses today, but you are going to be using it over and over and over again, and it'll make your life so much better. So you can also do it with subtraction. So the distributive property also works if you have A times B minus C, because that is going to come out to be AB minus AC. And similarly, you can do it in the other order also. B minus C times A equals BA minus CA. So that is pretty good. Let's take a look at a couple of quick examples. Well, we'll just do one for the sake of time. If you have an example, 3 times 2 plus 5 equals 3 times 2 plus 3 times 5. And that is equal to, well, we'll see why it works. This is 3 times 7, so it's almost like it's not really a proof, but it shows that it works. That's the same thing as 3 times 2 is 6, plus 3 times 5 is 15. So here we have 3 times 7, here we have 6 and 15, and we see that actually both sides come out to be 21. 3 times 7 is 21, and 6 plus 15 is 21. So it works. I haven't proven it to you, but it's basically one of those things that we take for granted and use all the time. And although it works with numbers, you're going to find it even more useful when you're using it with equations. So let's check out a real-world example. It's going to be example 1. So there is a group of 7 adults and 6 children. And they're going to a University of South Florida Bulls baseball game. Now, we're going to use the distributive property to write and evaluate an expression for the total ticket cost. And here you can see what the ticket costs are. So if you're an adult, your ticket is going to cost $5. And that's just if you're one adult, so one person by themselves. And if you're a kid, you're 12 and under, that's $3. If you're just one kid. If you are in a group of 10 or more, then for each person, it only costs $2. That's the group rate. And then if you're a senior citizen, even if it's just one person, that's going to be $3, same as the kids' price. So that's senior citizens for one person. So this is tricky. We have a group of 10 or more, but 7 of them are adults, and 7 of them are children. So how do we solve this problem? Let's first make sure we know what it's asking. So it says write, and evaluate. That means write it and solve it. An expression for the total cost. Remember that an expression is just a math phrase. And in order to do this, we need to first find the cost of each ticket. Now, we're going to use a little bit of a strategy first. By the way, strategy is called understand what we got to do, then you plan it, and then you solve it, and then you check it. So, we know what we have to do. Let's plan this out. So, we know that because there are 7 plus 6 people, that's 13 total, so the game tickets are going to cost $2 each. Done. Let's solve it. We need to write an expression that shows the product of the cost of each ticket and the sum of the adults and children's tickets. Let's try that out. We have $2 per ticket times adults plus children, 7 plus 6, which comes out to 2 times 7 plus 2 times 6. Oh my God, we used the distributive property. So then we can solve it. This comes out to 14 plus 12, which is 26. We are done. We have solved it. Actually, we haven't completely solved it because we didn't write the final answer. Final answers mean units. Total cost equals $26. That is our final answer. Now let's check it. That's our last step. Always check your work. The total number of tickets is 13, and then you multiply by 2, and 13 times 2 is 26. So it works. We have checked our work. Let's try using the distributive property to make mental math a little bit easier. This is a great trick. You're going to find yourself using it a lot. I love using the distributive property to do mental math because it makes you able to impress your friends, and then they think you're really smart, like you can do big things in your head, but really you just know what the how to use the distributive property. So this is actually example number 2 in your book, and it says use the distributive property. I'm just going to start calling it the DP, the distributive property, to rewrite 7 times 49 and then solve it. Let's try this out. Now 7 times 9, oh, not 7 times 9, 7 times 49. 7 times 49 is equal to, this is really just hard to solve in our heads. I wonder what would be easier. 7 times 50 minus 1. 50 minus 1 is got a lot simpler numbers than the number 49. So let's try splitting it up and distributing. 7 times 49 is the same as 7 times 50 minus 1, which is the same thing as 7 times 50 minus 7 times 1. Now we have 2 simple problems to do in our head. That's like 7 times 5 times 10, so that's 350. And then we have to subtract 7, which is, again, you can do that one in your head, 343. Done. As long as you can keep all the steps in your head and visualize how it breaks apart, then you can do pretty excellent mental math. And under check your progress for this example, there are a couple of other examples where it's a little trickier. One of them has a fraction, so we're going to do that. It is 2b. The directions are exactly the same, but we need to do it to rewrite 44 times 2.5. And the way I would split this up is to do 44 times 2 and then 44 times a half. So that's 44 times 2 plus 1/2. which comes out to 44 times 2, comes out to 44 times 2 plus 44 times a half. So that comes out to 88 plus 22, which, when we put it all together, gives us 80 plus 20 is 100, and 8 plus 2 is 10, so that's got to be 110. Hey, I used the distributive property in my head again. Oh my goodness. That's our final answer. And let me just highlight what I did there. I used the distributive property to add two numbers, not even multiplying. I just said that this is the same thing, and we jumped past it. This is the same thing as 80 plus 8 plus 20 plus 2. Then I used the associative property to be like, this is 100, and that's 10. Then I added those in my head, and I got 110. So really, if you get really good at using the associative and distributive properties, you can do pretty excellent crazy math in your head. Let's try the next one. Gotta move it up a little bit. Example number 3. We are going to use the distributive property to solve some a little bit more difficult, typically, expressions. So the directions in example 3, just to rewrite the expression using the distributive property, and then simplify. That means if it looks complicated, make it look shorter, make it look more simple, make it easy to understand. So, our first expression, part A, is 7 times 3w minus 5. Notice we have a variable in here, and that it doesn't tell us what number the variable corresponds to. This is what the distributive property is most useful for when we need to simplify. That's the same thing as 7 times 3w minus 7 times 5. I distributed it to each one. Now, this comes out to, you're using order of operations, 21w minus 7 times 5 is 14, 21, 28, 35. 21w minus 35. That's it. Now it's a little more simplified. Part of the reason we like to simplify numbers or expressions that have variables is that when you plug in your numbers later, especially if they're really complicated, like say I have to plug in eventually 0.7192 for w later on, and I want to use a calculator for it, it's great when I can just like plug that expression in my calculator and put 0.7192 in, and because my calculator can't do this part. I would have to use my calculator for like multiple steps. Or I can simplify it and then put this complicated value in my calculator for one step, which means I'm much less likely to make errors. Let's try part B now. A little bit more complicated, but still not bad. 6b squared plus v minus 3. This is an example of a quadratic equation. Quad, you know what? Quad means 4, but quadratic equations always have a squared term. So who knows why that is? Maybe you can tell me after you figure it out. It's a quadratic equation multiplied by the number 4 equals to 6v squared times 4, and distributing those top terms, plus v times 4 minus 3 times 4, which simplifies again to 6v squared plus, oh, I'm sorry, not 6v squared, 24v squared. You have to do 6 times 4. Let's scratch that out. And next line says, well, here we go, 24v squared, because we multiplied 6 times 4, plus 4v minus 12. And that is our final answer. Pretty good. Now, there are a few different things in Check Your Progress. I think going through this together should allow you to do it. Now, The next part, we have to use the distributive property, but we're also going to use it to combine like terms. That means that, well, you've probably seen it before, even if it's just a little bit. If there are variables that are the same, like x appears multiple times in your equation, you have to put it together with all the other x's. And then it makes it a lot easier to look at, easier to calculate when you plug numbers in. So example number 4a says simplify 17u plus 25u. Well, in order to combine the like terms, you kind of have to use the distributive property, technically, because to put these together, you're going to notice that this is equal to 17 plus 25 times u. That's how you know that you can put it together, which is again equal to 42 times u. Now, we can try that with another example, and then I'll show you a counter example. Sometimes people don't remember which terms you can't put together. So let's try simplifying 6t squared plus 3t minus t. Not too bad. This is going to be equal to 6t squared plus 3 minus 1 times t, which is 6t squared plus 2t. Not too bad. As a quick aside, now this doesn't appear in the check your progress portion, but I'll show you how sometimes you can't combine like terms. Like if you have example extra, if you have 6y plus 3x plus 2xy plus 4x. That's cool. What do you do with xy? Can you combine it? Actually, no. It has two variables stuck together. If you want to combine, that term can only, you could only combine this with other terms that also have xy. So if you saw in fact, let's do it. Let's add another term like that. If you saw a 4xy, you could combine with that one, but you couldn't combine with just x, and you couldn't combine with just y. Let's see how that works out. So there's only one y, so we'll leave that by itself. Then let's look at our x terms. There are two of them. Let's use the distributive property to combine them. We're basically doing the distributive property backwards. So we're getting 3 plus 4 times x plus 2 plus 4, right? We put these two together times xy. So that gives us 6y plus 7x plus 6xy. Now, I'm going to sit there. This isn't ordinarily what you do. I can tell you that this is our final answer. But what if I'm like, man, I really wish that I could combine that with the other ones. Let's see if there's a way. We could try it, but it just makes the equation more complicated. You would do, let's try to factor out of x, right? We're going to use the distributive property again. Let's do it. 6y plus x times 7 plus 6y, right? We just took that x and we pulled it out of each term. Now it's x times 7 plus x times 6y. Well, does that help us? No, not really. I just put back the parentheses. And I also can't combine with y because the same thing would happen. And that's when you either erase or go with your pen. And I'm guilty of doing that even up through college physics classes. Crazy. Because sometimes you forget when the distributive property doesn't work. But here, it doesn't. Let's take a look at our next example. Example number 5. We're going to use the expression twice the difference of 3x and y increased by the sum, increased by 5 times the sum of x and y. Well, this is a multi-step problem. We have to write and simplify an expression. So, here's what we're working with. Somebody tells you that you have, people do talk like this, not very often, but sometimes, twice the difference of 3x and y increased by 5 times the sum of x and 2y. Well, let's take a look at what these different words mean. So we want to go from words to variables to actually getting our final expression. Twice the difference. Twice means something gets to be multiplied by 2. The difference means something has to be subtracted, and that difference of 3x and y, this part is what's going to get subtracted. The difference of 3x and y increased by, well, something has to get added on, because increase, you add it on by 5 times the sum. Okay, so something gets multiplied by 5. And then we've got the sum of x and 2y. The sum of means that the expression, like whatever words come next, are in parentheses, and it's the sum of them, which means you have to add them. So let's translate this. We'll take our little notes. 2 times, so we took care of that, the difference of 3x and y. So 2 times, and then this is not an x, it's a times symbol. Let's make that extra clear. 2 times the difference of 3x and y. That's 3x minus y. Or it could be y minus 3x. But usually you put the first one first. Increased by, that means I have to add on the next part. It always goes in order. Increased by 5 times the sum of x and 2y. So that's x plus 2y. We have got it. 2 times 3x minus y plus 5 times x plus 2y. So we have written an algebraic expression. Algebraic. Now we have to simplify it and indicate the properties used. So this is example 5, part B. Let's simplify it, and every time I do something, I'm going to write out what property I used. So I'm going to start by rewriting it. 2 times 3x minus y plus 5 times x plus 2y. Notice it doesn't matter if I have the dot because the parenthesis is also there. It just helps us find things. So let's start by distributing. I'm going to call this the distributive property, dp. Well, when I distribute, this gets to be equal to 2 times 3x minus 2 times y plus 5 times x, this part we're on now, plus 5 times 2y. Now, if that was a little fast for you, you can pause and then go back to it. So, but fortunately, we've got all our stuff here. It's pretty much right below whatever it was with before. Let's try simplifying again. In this part, we just have to multiply. That is the step that we are using. Well, 2 times 3 is 6, so that's got to be 6x. 2 times y is just 2y. 5x is just 5x. And this part is going to be 10y. 5 times 2 is 10. Now, let's try grouping some stuff together. That would be the commutative. Because I have x and then y and then x and then y, I really want to put them together. So let's do 6x plus 5x. when I group things together in preparation for like adding or subtracting them, then that would be commutative. You know what? We don't really need the parentheses yet. That is another property. So 6x plus 5x, I just moved it over, minus 2y plus 10y. Now I have done the pure commutative property of addition. Let's try the distributive property now. Again, I'm just going to write dp for speed. This is going to be equal to 6 plus 5 times x. So I move my 6 and my 5 over. And this is going to be, well, if I put a plus sign there, then the negative has to stick with the 2. Otherwise, I can do minus, but that gets tricky. You'll see more later. Plus negative 2. So I'm adding, but then like I have this negative sign, so we can pretend this is like plus a negative 2. If you're not sure on your positives and negatives, remember that minus something is always the same thing as plus a negative. So plus negative 2 plus 10 times y. Done. Now I have to substitute again. I'm going to call it substitution. So that gives me 11x plus, what's negative 2 and 10? Comes out to 8. 8y. And that's my final answer. I'm just going to rewrite it down here all close together like 11x and 8y. Done. That's it. You can try the next part on your own if you'd like. Now, sometimes we find that it's useful to combine the properties of numbers, like commutative, associative, identity, zero, distributive, and substitution, and use them all together. But you'll actually be seeing this when you work on your homework tonight. So if you have any more questions, feel free to ask in class or post.